Hey everybody, welcome back to my series on the operating system that I am building for the IBM XT. In this video, I want to cover a couple things. First, I want to show you the web page. This is os8088.com. You can find all the information about the operating system. You can go up here and you can see how it works. You can see screenshots. You can go to the downloads page and figure out how to download it and run it on your machine. So a lot of information here on how to get started. You can see the releases page, which explains all the changes that are happening in each release. And we'll go over that in this video because there's a couple. That's the second thing that I want to talk about, what's changed since the last video. You can see the video feed like this one. If you want to go directly to a place where you can see the latest videos, this is automatically updated every single time I upload a video. It picks it up. And there's a live demo page. So if you go here, you can click and boot the machine. And if you press capture pointer, you're in it. So you can go to the disk. You can run Minesweeper. All of this. So that's all in there. And it looks like I have to update this image because, or maybe I have it cached. It's probably that I have it cached. Cloudflare likes to cache. To get out of here, you have to press escape. And then, as you can see here, you have to press escape. And then your mouse is free again. So, yeah, you can check out the operating system here and give it a shot. What else? And if you go to special, then you can go to the source on GitHub. And what I'm doing now is you have releases. You go to releases on the right-hand side, and then you have what changed in that release, and then you have all the assets down here that you might need for your to create your images. So you can see here, this is a previous release. So what I'm going to talk about now is in the last video, I had an issue with building double buffering. It was built, but it was built in a non-performant way. And what I ended up doing is I said, okay, what if we can make that optional? For some machines, the faster they are, that double buffering will work really well. Whereas in the IBM XT, probably not. So what I ended up doing is I created optional double buffering, which we'll take a look right now. It's switchable at runtime from control panel's new display page, off by default on every machine. A 256K machine draws straight to VRAM as before and can never leave that path. At 500K or above, I chose 500K because some machines with 512K, they use some of the RAM they reserve it for something. So I just set a 500K, you need at least 500K to be able to use double buffering. Because double buffering requires that you use 150K for the buffers. Or more of conventional allows a 4-plane back buffer at segment 4000. Flushed a dirty rectangle at a time when the drawing dropped. Okay, two things keep it affordable. While everything on screen is black and white, all 4 planes are identical. So the flush writes one plane and lets the map mask fan it out. And the transient or overlays drag out bypass the buffer entirely. Okay, so that is what made it performant. So since we're taking advantage of the fact that a lot of it is in black and white, and instead of having to update 4 planes, it'll just do 1 for the black and white stuff. But for the color stuff, like the Minesweeper game, you're in the XT, you're still gonna see that 4 planes getting drawn, and there's no way to speed that up unless I create an accelerated video card just for this operating system, which I've thought about because why not think about it, but for now that's I have to be really bored to do that one. So or not even bored, like have nothing else going in my life to build a graphics card for the XT. So if you're interested in doing that, go ahead. Help me out. But other than that, that's not going to happen. But I should probably run this on a real machine before before we go building specialized hardware or GPU for the XT. All right. So the other thing that we added is a graphical boot splash, a spinning 8088 over a progress bar, and then the 640 kilobyte boot targets. I think I showcased all of those before in the previous video. But the main change was this, all of this, what do you call it? The double buffering fixes. The other thing that I did was I was constantly getting messages about the fact that we're running out of headroom in the kernel. So this next release, the latest one that I just pushed 24 minutes ago, is a memory release. The task stacks, the disk buffers, and two of the coldest modules move out of the kernel 64 kilobyte segment, taking the headroom set left for future features from 1000 bytes to 28 kilobytes. All right, so what does this mean? In the XT, we're working with memory segments that are in 64K chunks, and that means that our assembly, to have relative addressing, everything is kind of being addressed within that 64 kilobyte segment. And in order to be able to build more into the kernel, I had to move some stuff out of that 64 kilobyte segment into other regions of memory to free up and create more room to grow the kernel. So that's what this release did. This release restructured some things a bit. So what did we do? The kernel was not short of memory. Let me just increase the font here. It was short of segment. Everything it touched through DS had to fit in one 64 kilobyte window, and 59% of that budget was uninitialized scratch. The task stacks alone, 11 of them at 1.5 kilobytes, were 41% of the window. 3 moves fixed it. The stacks and the floppy buffer went to their own segment at linear 0x08000 and in low memory that sits free on every machine once the boot sector hands off, which is 20 kilobytes back. Cool. So the floppy stuff, the floppy drive buffers, they were moved out of the memory of the 64 kilobyte because it doesn't have to be there all the time. The package pool slid up from 0x8000 to 0x B000. I don't into the 4 kilobyte that tasks 0 stack used to occupy. Okay, so moving more stuff about the package pool. And 2 cold modules, the control panel and task manager, now assemble into FAR segment that is copied out of the kernel in image at boot and lands on top of BSS 2.9 kilobytes of code that cost the window nothing. All right, nothing left conventional memory and nothing on screen change. So a 256 kilobyte machine behaves exactly like before. Okay. The RAM figure means something different now. That size said 39 bytes last release and says 16,000 this one. No code was deleted. The number counts what the kernel keeps inside its own segment, and the stacks and disk buffers that made up most of it still exists, just at another address. The ceiling moves too, okay, before the package pool moved with it. The task manager's RAM total and system row both add back what now lives outside the segment source. All right. So yeah, we have more headroom. That's basically it. We have more headroom to grow, and that's great because now we can continue building stuff. I can add different types of video support. I can add sound. I can add all this stuff, and I think it'll continue to be possible because I think I can. The next thing is to make everything modular. So that's one of the things that I think. Let me see here. Where is that? I don't think I have. Do I have docs here? Memory plan. The last one. FAR code modules. Okay. And then this was the last one. So we do have the ability to have far code modules. So that means that we can extend the kernel as far as we want, I think. All right. Now, the next thing that I'm actually building as we speak here is a better task manager that takes into account all the memory changes that we did. So I am building a task manager memory map view so that you can actually see where in the memory map the applications will land. So let's let this run, and then I will, as soon as this is done here in this video, and with the magic of editing, I will be able to show you all of the changes that I just discussed. All right, so it finished here. So let's go for it. Let's see what this is. Let's run it with make xt, which is a 256 kilobyte machine, and I don't expect. Let me see what the memory map looks like here. So in this machine, there is not going to be any double buffering. Everything should continue to work as expected. The memory changes should have taken place here because we do have 256 kilobytes, more than 64 kilobytes. So we do have more space to work with even here. And okay, so you can see here, this is the little spinning thing. All right. All right, so here we go. So we have bounce. I'm gonna move it over here. We have mine sweeper. Move that over here. And close this window. And task manager. It doesn't show. Oh no, if you click on it. All right, so you have to click on it to see what we have. So we have system takes up, what is this? So we have 44 kilobytes of 256 kilobytes used. What is that thing? Oh, you can see here that we have Minesweeper all the way over here. You have part of the system all the way over here. And then you have a pool of memory. So this is a memory pool. So that's what we have. So let me see if I do. Clock. Clock is inside that memory pool. So that's why it doesn't use up any RAM. But if I load up another application like Notepad, where does that end up? All right, Notepad ends up right here in that segment right there. Oh wait, so I click on 64K pool. I have no idea what I'm looking at here. RAM, 45 kilobytes of 256 kilobytes. So, and then you have this, which is a 64 kilobyte pool. All right, so at least now you can see the Notepad is over here. Minesweeper is over here. The system is over here in this 64 kilobyte segment. And oh, okay, so this is a segment, the pool of 64K segments. All right, so that's where it's showing up. Okay, so let's boot up the 640 kilobyte machine. This should grow even. This should just scale differently. So let's see how that works. I'm gonna close this out and then make XT640. All right, so almost there. Okay, so here it is. It's loading. All right, so now let's go to the task manager first and click on it, and we have, oh, okay, so these are the 64K chunks, and then these are the segments. I really don't know how to make sense of this, to be honest. And if I load Minesweeper, okay, so we have Minesweeper over there, and then another Minesweeper. So we have two Minesweepers, so that now we're gonna have two right there, back to back. Oh, this is the memory space right here. 000 system, B0000 mines, B800. Okay, and if I have Notepad now, C000 with 1K. So it's doing a good job of like placing all those programs into memory right there in those segments far away. All right, very cool, very cool. So at least we can visually see what's going on here and have an idea of what we can work with. So does that mean, well, does it mean it does? I wonder if our packages have a limit of like 64 kilobytes. It might be enough for most applications. Well, not most, but many applications that we can build should fit in 64 kilobytes. So we'll see. We'll see how far we get with that. At that point, we'll have to figure out if we can do packages that can use different parts of the memory space through an official the official SDK. All right, so I think that was it. That was it. So we changed the, oh, the other thing I want to show you is the control panel. Now let's change double buffering. So if I do this now and I go back to the task manager, oh boy, that slowed down a lot. Oh, why did I do that? Oh, because of the because Minesweeper's in the background. All right, I don't know what happened to the double buffering here, but it got really slow. Yeah, double buffering is something that is not great for this operating system. So let me close the color apps. And as you can see here, look at the task manager, like the memory usage. It took up 150 kilobytes of space up in that pool. So let me see here. All right, I'm closing that. Oh, I wonder what happens if I restart. See, I'm gonna leave Notepad running, and now see that I wonder if it's gonna reclaim the RAM if I run. Okay, I don't know why the black and white stuff doesn't work anymore. It was actually running really well. Okay, as you can see here, it's running well when I'm dragging now, but double buffering, not a good thing. Not on the XT at least. And look at the, when I close applications, look at the taskbar. down here, it doesn't shift over the icons. So it's crazy how much state an operating system needs to have. So now I'm curious. Let me switch out of this double. Well, let me leave double buffering on and see what happens. So I'm gonna run mines now, and it would be great if one of these slots gets taken up and it doesn't just add it on to the back here. So let me see. Otherwise, I can see us running out of memory space if we, let's say, run a bunch of applications and then close one of the first ones. Let's see what happens if it's smart enough to reclaim RAM. Oh, it did it. It went to it found the 2 kilobyte chunk and then added in there. Great. All right, so it reclaims the memory space. Great. All right, well, I just wanted to show you that. Unfortunately, the double buffering doesn't seem to be working correctly. So I'm not sure what's happening there. I think the black and white stuff, it should be fast, but it's not. It's still doing 4 planes. So something either broke or with the memory changes, or I was imagining things. Most likely something broke, so I can iterate on that and see if I can fix it. But double buffering on the XT, probably not gonna be it. All right, well, I hope everybody liked this video, and let me know in the comments what you thought. If you see anything that needs to be changed or fixed, happy to take that into account. And until next time, thank you.